All right, here we go. This is actually our first lesson of Algebra 2. And you're going to see here, starting to see the major differences between Algebra 1 and Algebra 2, because these are a review of concepts, because you've done all these concepts before. In fact, you've done it writing equations of lines. You've done that in Algebra 1 and geometry. We did a whole chapter, actually a couple sections on parallel and perpendicular lines and writing equations for those. So this should be a little bit familiar, but you're going to see we're going to go in depth and actually talk about like where these things come from. So let's just jump right in, and we'll talk about the four different forms of equations that we have here. So slope formula, we know slope. Slope is we use little m, and that's described as the change of y over the change of x. The triangle being a Greek symbol, that means delta, which is change. And that's always our constant. God, I didn't know if I spelled that right. Our constant rate of change. So it's how the graph changes. It's how do we get from this point to this point in a graph? Well, we can do that in a formula. You may remember this. The slope is going to be y2 minus y1 over x2 minus x1. That looks like a y. Now, it doesn't matter if you want to do y1 minus y2 and x1 minus x2, as long as the twos both the twos come first or both the ones come first. But you see it always written as y2 minus y1 and x2 minus x1. Because it's just saying what's the difference in the x and then what's the difference in the y. How else do we find slope? Well, simple in a graph. We can use a graph, I should say, if we're given it. It's always our preferred thing if we just have a graph given to us. And slope is going to be rise over the run. So if we have 2 points, and you can connect them either way you want to. I might say rise and run if I'm going to go left to right. Well, I'm going up 1, and then right 1, 2, 3. Up is positive, down would be negative. Right is positive, left is negative. So if we did it the other way, we would have down 1 and left 3, starting from this point, going down and then left. So you just have to be careful about those kinds of things. Okay. We have other forms. We have point slope form and we have slope intercept form. You guys are most familiar with slope intercept form, I think. Point slope form has not been used in quite a while, actually. You may or may not even remember it, actually. When you look at slope intercept form, let's talk about this one first. We're going to go slope intercept form. We have a line, any point that's on the line, x and y, and then the y-intercept, which is going to be 0, and then b whatever it is on the y-axis. Well, if we want to say, like, okay, this is, I don't know, we could say this is x1, y1, sure, x2, y2, and let's use our slope formula and just find the slope. Well, y2 minus y1, so in this case, it's going to be y minus y1, which is b. In this case, y1 is b. So y minus b all over x, x2, minus x1, which in this case is 0. Well, and then that actually simplifies x minus 0 is just x, right? Well, what happens if I just manipulate this equation a little bit? Like, what if I want to get y by itself? Well, multiply both sides by x. So I have mx is equal to y minus b. Whoa, I add b on both sides, and all of a sudden, y is equal to mx plus b. So this actually comes from the slope formula. Something we should, we're all familiar with slope intercept form, but it actually derives from slope. You probably didn't realize how much slope has to do with all this stuff. You talk about a lot in geometry, finding slopes of parallel and perpendicular lines. But now we're like really going deep. So let's go to point slope form. Now, point slope form is my favorite form because it's everything you want, right? It's got If you're given a point, you plug it in, and then you have a slope, you plug it in, and it'll give you the equation. It works all the time, which we can probably use. You could imagine we're actually going to use this from slope formula. Let's start again. Let's write slope formula out. M is equal to y2 minus y1 over x2 minus x1, just from those points there. Okay. Let's do this. Let's put m over 1, because 2 is also equal to 2 over 1. So we'll put m over 1. And let's do a little bit cross multiply. So we're going to get y2 minus y1, 1 minus y2, 1 minus y1 is just y2 minus y1 equals m times x2, which is, we're actually going to leave it like this. It's a much simpler derivation. And what we actually do is x2 and y2, we're just going to leave those as y's. We don't need to have extra subscript numbers down there. So we'll just leave the ones, and then we'll just get rid of this extra subscript because we don't even have just regular ones. And we're left with our point slope form. I like point slope form a lot. You'll really see how handy it is when we get down to the bottom here. And then the last one is standard form. Let's do ax plus by equals c. And so you're going to see something cool happen here in standard form, actually. Let's isolate y. That's kind of what we're used to, right? We're used to isolating the y. So let's subtract ax. Okay. Which means I have by is equal to negative ax plus c. And then divide everything by b to get y by itself. Which means I end up with, let's use pink, y equals negative a over b x plus c over b. Well, that tells us some things, because if we're thinking of this as slope-intercept form, right? mx plus b, that means negative a over b is our slope, and then our y-intercept is c over b coming from this. So you'll see it's actually quite helpful. All right, let's actually get it's going to make a lot more sense as we go. It's a good learn by do kind of skill. So I bet there's a lot of questions and confusion going on right now. So when we jump down here into these examples, we actually need to write the equation. So I totally just lost my train of thought. That was so weird. Writing the equation, line has a slope of negative 3 and passes through 0, 4. It's good to think like, what information do they give you? So with even ignoring the whole graph, if you just think it has a slope and it goes through a point. Okay, well, maybe we should graph it, I should say. It goes through 0, 4. 1, 2, 3. Wait, that's our y-intercept. So we have a slope and a y-intercept. Which one should we probably use? Well, we look up at the top and we see, okay, slope-intercept form has a slope and a y-intercept. So we end up with y equals negative 3x plus 4. And then quick review on graphing, if the y-intercept's 4, 1, 2, 3, we go up to 4 on the y-axis. The slope is negative 3, which means we go down 1, 2, 3, and right 1. And we repeat. 1, 2, 3, and right 1. 1, 2, 3, right 1. I got this nifty thing here. And I can make a nice straight line through my points. Remember from geometry 2, lines have arrows. That means they go on forever. If you don't include arrows, it's just a line segment. Okay, so that's slope-intercept form. That's probably the most comfortable and familiar that we're all used to here. Let's take a look at point-slope form. Yes, I love point-slope form. If it has a slope of 2/3 and it goes to the point -6, -5. This is our x1, our y1. Because we have y minus y1 is equal to mx minus x1. So we have our x1 and our y1 where these are the point. And m is our slope. We can just plug it in. Y minus, what is y1, which is -5. Ooh, negative and negative make a positive. Equals our slope, which is 2/3. X minus x1 is -6. Oh, negative and negative make a positive. And now I can simplify this so I can get my answer in a slope-intercept form. So let's start, let's distribute this guy. So we have y plus 5 equals 2/3 x. And when we distribute fractions, it's always multiply the top. So 6 times 2 is 12 divided by 3, which is going to be 4. And then just to get y by itself, we subtract 5 on both sides. And y is equal to 2/3 x plus, minus 1. Great. We can graph that now. We know slope-intercept form for graphing. We go to -1. This is our y-intercept. Go up 2 and right 3. You could go down 2 and left 3 as well. Do the complete opposite. So you have an extra point. And then make your straight line. I know there's OCD people out there who are going to see me make a straight line that's going to look like that. That's not straight and freak out. So that's for you, straight lines. Very nice. And this isn't a lot of work right there. It does not take a lot of work. Okay. Moving into our last two examples here. We're going to go from the graph now. So the graph shows the remaining balance on a car loan after you make so many monthly payments. This is a good graph, actually, because it's very true. I'm still making car payments. Remaining on your balance y and on your car loan after making X amount of monthly payments. Write an equation of the line and intercept. Oh, interpret. Sorry, can't read. The slope and y-intercept. Well, this is giving us 2 points, which doesn't really tell us too much, but why don't we find the slope? Especially because we know our y-intercept's right there at 0, 18, right? So we could do, we know it's going to be y equals something x plus 18. We just have to find out what that something is. You maybe remember from last year, you got to take, or from algebra, you got to take one of these 2 points. We'll take this one right here, 10 and 15, and plug it into our equation. And all that's going to be left, we have an x and a y, right? So we have 15 is equal to m, x is 10, plus 18. And look, all we have left is m. So subtract 18 on both sides. We have -3 is equal to 10m. And then divide both by 10. Wow. So our slope is -3/10, which we'll put in there to get -3/10x plus 18. If you want to use a decimal, that's okay. In fact, I'm going to use a decimal just to make it a little bit more organized. -0.3. So yeah, what we need to interpret. I'm going to actually get rid of this real quick. We need to interpret what the slope actually means and what the y-intercept means. So let's see. Right, it says interpret. So the slope, let's start with the y-intercept right there at 0, 18, where x is 0, which is number of payments. So 0 payments. This is y is thousands of dollars. Oh boy. 0 payments. So after 0 payments, or with no payments, I owe $18,000 on my car. It's actually not that bad. What does the slope tell us? The slope is negative 0.3. Slope tells us that I'm paying off the car each month. I pay 0.3 of the thousands of dollars. So if you have $1,000, what's 0.3 of it? $300. So each month I pay $300. Or that's why I actually like to leave it as negative 3 over 10, because if you do that, you're saying every 3 months I'm paying. I'm sorry. Every 10 months, because 10 is your. Remember, this is change of y over change of x. So my change of x is 10. So after every 10 months, I am paying off $3,000. So there's multiple ways that you can interpret this. Then what is the remaining balance after 36 payments? You make payments a month. That's why I've interpreted that as months. Well, 36 is payments, which is x. So x equals 36. We'll plug that into our equation here. So y is equal to negative 0.3 times 36 plus 18. Let's see, negative 0.3 times 36 plus 18. I'm using my calculator here, which is 7.2. And that's 7.2 thousands. So I want to times that by 1,000 times 1,000. And so 7.2, I really should be able to do this in my head, but it's not working for me. $7,200. Okay, we are so close to being done. I know these are a little bit longer than yesterday's notes. I apologize, but we're almost done. Last example. Kelly and Kim are both babysitters. Kelly charges a flat rate fee of $10 plus $6 per hour to babysit. The table shows total hourly fee that Kim charges to babysit. So if it's only 1 hour, she charges $22 as a total fee. 2 hours is going to be 26. 3 is 30. There's a little bit of a little deal going on there, it looks like. So we don't have to see who charges more, or who charges more per hour. How many hours must Kim and Kelly babysit for their fees to be the same? Well, this is Kim's babysitting fees, and then Kelly is just a straight equation: $10 plus 6 per hour, so 6x. So y is equal to 10 plus 6x, and that's Kelly. I underlined her in green. Blue is going to be Kim. Well, let's see. Kim, if this, we're adding, what are we doing? We're adding 4. Adding 4. So if we went backwards, we want 0, right, for our y-intercept. We would subtract 4, which means our y-intercept, in theory, should be 22 minus 4, which is 18. Plus 18 is positive 18. She's getting money. And then what's the chain? What's the slope? Because we need something x, right? What's the m? What is our slope? Well, if we think of this as x and y, we know slope is change of y over change of x. Well, how does the y change? What do we do each time? We're adding 4. So our slope is positive 4 for our change of y, and our change of y, and then our change of x. Oh, that's nice. It's just changing by 1. Positive 1. Positive and positive is a positive. 4 over 1 is just 4. So our slope is 4, which is going to be representative of our hourly fee, right? 6 per hour, 6x, which means Kim is 4 per hour. So who charges more per hour? That answer, I should use a different color. We'll use red. It looks like it's going to be Kelly up there. And the last one is, how many hours must Kim and Kelly babysit for their fees to be the same? Well, the easiest thing to do is they both are equal to y. You guys might remember the transitive property from geometry, right? It was like if a then b, but if b then x, therefore if a then x. Transitive property works here in math too. If 10x plus 6 equals y, if y equals 4x plus 18, then we can cross this off and then we can set these two equal. But basically, since it wants to know when they're going to be the same, we want to set their work rates or their pay equal to each other and find out. So 10 plus 6x is equal to 4x plus 18. Subtract 4x on both sides. I'm going to do another step at the same time here. I'm going to also subtract 10 on both sides. So I have 2x is equal to 8. And dividing both sides by 2x equals 4. So the answer is 4 hours, and then their rates are the same, which we can actually see here. That would be $34. That's really cheap for babysitting. All right, that's all I got. I'll take plenty of questions on these notes tomorrow. Go over a couple quick things, and before we get into our in-class practice, where I'm going to be helping a lot more students. Okay. So yeah, I will see you in class.